Hello, how are we doing today? In this video, I'm going to go over this example right here. These three lines here, here, and here. And guys, in the editing, in this video, I forget some of the letters. This is the correct version of the bottom line. When I get to talking here in a second, I forget some of these letters. Here is the correct answer. Now, later on in the video, I'm going to retype these back in. They're fixing to disappear. Some of the letters that need to be here are going to disappear. That's because I made a mistake earlier, but I've came back and edited, and I wanted to show you the correct answer. Some of you I know will read ahead, and I didn't want you to get the wrong idea. So this is the correct answer here, but a minute ago I forgot some of my letters. I think I forgot like a T or a U or something like that, or both. I forgot some of my letters, so I wanted to come back and edit and recapitulate and let you know this is the correct answer. I didn't mess up anything here or here, but I messed up this third line. So just, I fix it in the video, and what's coming up, I fix it, but it takes me, I don't fix it until toward the end of the video, and right now. So here's the correct answer. So let's move on and talk about this example. Let's say I've got the fourth root of 6,250 times all this stuff here, where my cursor is. Well, notice that I'm doing the fourth root, so I need to find the largest multiple of 4 that is smaller than that exponent. For example, for p, I need to find the largest multiple of 4 that is smaller than 5, which would be 4 itself. For q, I need to find the largest multiple of 4 that is smaller than 6. Again, that would still be 4 itself. Now for x, notice 8 is already a multiple of 4, so we don't mess with it. We move on to the next letter. Y to the ninth, the multiple of 4 that is the greatest multiple of 4 that is smaller than 9 is 8. So 8 is going to be my choice here in a minute. And then likewise for z to the 10th, 8 is going to be my choice again. It is my largest multiple of 4 that is smaller than 10 for z. Okay, and for w I have 11. 8 is again my choice. Now the number 8. Now for the letter A is an apple. Notice it's to the 12th power. 12 is already a multiple of 4, so I don't mess with A to the 12th. I'll leave it alone and move on. Now B to the 13. The largest multiple of 4 that is smaller than 13 is 12. So I choose 12 for B. And in a similar fashion, I choose 12 for C and 12 for T. However, U is to the 16th power, and 16 is itself a multiple of 4, so I leave U to the 16th alone. Now, so what I do is I go down here to this next step. Now, I want to break, 6250 is not a perfect fourth power. It's not the fourth power of any clean integer, I should say. But I can break it up into 625 times 10. Now, 10 isn't going to go far at all. 10 is not a perfect cube by any stretch. But 625 is a perfect cube. Not a perfect cube. Back up. 10 is not a perfect fourth power. It's actually not... I don't need to be talking about cubes, I need to be talking about fourth power. Sorry, I've got my mind on the last video. So 10 is not a perfect fourth power, not even close. Now 625, it is a perfect fourth power. It is 5 to the fourth power. 625 is 5 times 5 times 5 times 5, or 5 to the fourth power. So what's going to happen is, and this 625 should come out as a p. And by the way, guys, all these variables are assumed to be positive, and we're going to do the fourth root and the fourth power. We're not doing cubes anymore or cube roots. If I said the word cube root a minute ago, then forgive me, I should have said fourth root in this video, because in this video we're talking about fourth roots. Now my last video, I was talking about cube roots, but in this one we're talking about fourth roots. And all variables, letter you see is positive. Now, here's the dig. 625, I take the honest to goodness fourth root of 625, that's 5. Now, what I do here, but now let's move on. Now, before I start taking other stuff out, notice that 10 is going to stay in here. But anyway, let's look at the letters. P to the fourth, I break up P to the fifth. You remember how I chose 4, how 4 was itself the biggest multiple of 4 that was smaller than 5? So I break up 5 into 4 plus 1. So I put p to the 4th here, and p to the understood 1 power here. And q is to the 6th power. Remember, 4 is my choice. It's my biggest multiple of 4 that is less than 6. So I turn 6 into 4 plus 2. So I've got q to the 4th here, and q to the 2 power here. Now, x to the 8th, we left it alone. 8 is good. It's a multiple of 4. Nothing more to say. Now, y to the 9th, now 8, for relative to 9, 8 is the biggest multiple of 4 that is smaller than 9. So I break up 9 into 8 plus 1. So I break up y to the 9th into y to the 8th here times y to the 1 way, but I move y to the 1 way over here like I've been doing the others. And this is understood to the 1 power for y here. Now, for z, again, for z has a 10 power on it, so 8 is my biggest multiple that does not exceed, multiple 4 that does not exceed 10. So I break up 10 into 8 plus 2. So z to the 8 here, z to the 2 here. And then, now w is to the 11th power. So again, 8 is my choice. It's the biggest multiple of 4 that does not exceed 11. So 8 plus 3 is 11, so w8, w to the 8th here, w to the 3rd power here. And now a is an apple. Remember, we left it alone. 12 is already a multiple of 4, and it's all about the multiples of 4 in this problem, and because we're doing the 4th root. Okay, now b to the 13, again, well, 12 is obviously my choice, so 12 plus 1, I turn 13 into 12 plus 1, so b to the 12th here, b to the 1 here, and then c to the 14th, 12 plus 2, so c to the 12th here, c to the 2 here, and 15 is, now 12 is still the biggest multiple of 4 that does not exceed 15. So we turn 15 into 12 plus 3, so t to the 12 here, t to the 3 here. Now 16 is a multiple of 4, we don't mess with it. U to the 16th, for now anyway, we don't mess with it. So u to the 16th just comes down. Nothing more to say. We just leave it be. Okay, and here's my other stuff, the stuff that was left over. And notice what's going to happen, guys, is this stuff right here on the left side. See this? We have this times sign right here where my cursor is. On the left side of this times sign is my stuff that will come out. On the right side of this times sign is my stuff that will not come out. Okay, as we talked about before, we do the 4th root of everybody. So the 4th root of 625 is 5 from what we said a minute ago. Now, p to the 4th, remember, since we're doing the 4th root, we divide all the exponents by 4. You know, had it been the 5th root, we'd have divided them all by 5. Had it been the 6th root, we'd have divided them all by 6. And I would have been doing the multiples of, for example, the 6th root, I'd have been finding multiples of 6 instead of multiples of 4 had we done the 6th root, which we're not doing in this case, but I'm speaking hypothetically. Let's come back now and do the 4th root, which is what we're doing. Okay, so the 4th root of 625 is 5. Now divide all the exponents by 4. P to the 4th comes out as p to the 1. Q to the 4th comes out as q to the 1. X to the 8th, now 8 divided by 4 is 2. So it's x to the 2 power, or x squared, that is. And then y to the 8th, again, for the same reason, that's y squared. Z to the 8th, similar idea, that's z squared. W to the 8th, similar idea, that's w squared. Now, a as an apple is raised to the 12th power. We divide 12 by 4 to get 3, so a12 comes out, a to the 12th comes out as a cubed. And then times, I put this times sign here because in this program I'm using, Word, it doesn't look good when I don't. When you're writing on pencil and paper, you can just smack all this together. You can smack the radical on these, but when you're typing it, when you're writing it with pen and paper, but for this, it's just nicer to have the times sign. So I do the times sign, and then I draw my 4th root, and I just put down all the stuff that got left inside here. And you know what? I think I made a boo-boo. I forgot, and yikes. So now my T12 comes out. I forgot my other stuff, didn't I? Sorry, guys. I forgot some of my letters. So what all got left out here? So I've got my B to the power of 3. I've got my C to the power of 3. Sorry about that. I've got my T to the power of 3, and I got my U to the power of 4. Sorry, that's a U. And then did I remember my other stuff? Yeah, there is. Notice, okay, sorry, I forgot my stuff. That was my honest mistake on my part. My bad. So I've got all this stuff here. And let me just make sure I've not forgotten anything. My P, my Q, my X, my Y, my Z, my W, my A, B, C, T, and my U. And notice that U, since C, T, and U, well, no, I take it back. No, back up. Let's go back up here. Notice U was already raised to a multiple of 4, namely 16. So there's not going to be any residue of U here. Now, the only other guys that qualify, A to the 12 is another one, so there's not going to be any letter A's over here. And X to the 8th, so there's not going to be a letter X over here. And that's it, though. Everybody else has a residue. Notice that now for the coefficient of 6250, we broke it up into 625 times 10. And the reason why do we crave that 625? Because it's a perfect fourth, it's the perfect... it's a fourth power. It's the fourth power of a positive integer, namely 5. That's why we wanted to separate that 625 out of that 6250, and we wanted to turn 6250 into 625 times 10. That 10 is just the residue that's going to stay in, but the 625 comes out as a 5. You do the honest to goodness fourth root of 625, and you get 5. And let me just pour over this just to make sure I didn't forget anything. Sorry about my sloppiness there a minute ago. But, so there's all that. And looks good. So, yep, it's all there. I'm not going to go any further. That example was very heavy, and I think this would be an appropriate time to stop the video. And before I quit, just let me point out, if this would have been like the 6th root, I would have went searching for all the multiples of 6 that don't exceed that exponent. Like, for example, if this would have been the 6th root of, well, 6250, nothing would have came out. All this 6250 would have stayed in. Because there's nothing that could have came out. That's actually not true for the 5th root, but it is the 6th root. Now, the 5th root things would have happened in a different way than they happened here, though. So, but let's just say I did the 6th root, the even number 6. The 6th, let's say this was a 6 here. Then I would go, P to the 5th wouldn't come out at all. It's stuck in there. He would actually just be stuck. And now Q to the 6th would actually come out as just Q, and there would be no residue. X to the 8th, well, it would turn 8 into 6 plus 2. X to the 2 would stay in, and that X to the 6 would go out as just X to the 1, so on and so forth. That's what would happen if this was a 6 instead of a 4. That's not the same problem that we did. Like, I'm just pretending for now this was a 6th root. It's not. But if it was, we would know how to handle it. So what would happen is 6250 would stay inside, the whole thing would. We can demonstrate why that's true later. The P to the 5th would stay inside because 5 would be too small. Because 5, if this was a 6 here, 5 would fall below 6 and it couldn't come out. But now in this example, that wasn't the case because 5 is bigger than 4, and we could go searching for a multiple of 4 that the greatest multiple of 4 that didn't exceed 5, which is 4 itself, of course. But anyway. So I just want to show you how to handle it. What if this wasn't a 4th root? What if it was a 6th root or a 5th root or a 7th root or an 8th root or a square root? Remember back in the days of the square root, we just go looking for the even stuff, the multiples of 2, which is even stuff. With the cube root, we go looking for the multiples of 3. Like if this has just been a more humble cube root, some stuff would have came out. It would have been in a different way. You'd have to go in and do some stuff with the 6250. You would, instead of turning 5 with the cube root, you'd do 3 plus 2, and the P to the 3 would come out as P to the 1, and the P to the 2 would stay in. That's assuming this was a 3 this time, right here where my cursor. So I'm just playing with hypothetical scenarios that I didn't type down on the page here, okay? So I hope this helps. I did the 4th root. Everything you see on this page is when we use 4, and we went searching for the greatest multiples of 4 that did not exceed the exponents. And we broke up the 6250 in the right way. Now, if we were doing the cube root and the 5th root, stuff would come out, but it would be in a different way. I'd have to break up the 6250 would break up in a different way. things would come out, but it wouldn't be in the same style. It'd be a little different. But that'd be all for this video. Thank you very much.